On this problem, what you want to do is you want to take the antiderivative of 1 over square root of x, and because you want to do the integral from 4 to 9 of 1 over the square root of x, which is the same as integral from 4 to 9. I'm going to rewrite 1 over square root of x. That's x to the negative, because it's on the denominator, 1/2 because it's a square root. So that'll make it a little easier to find my antiderivative. I always forget my dx, but anyway, we're going to take our antiderivative, which means we need to add 1 to our exponent. So if we add 1 to negative 1/2, we get positive 1/2, and then we have to divide by that. And then we're going to evaluate that from 4 to 9. And I am going to rewrite that again because that's a little messy. That is, if you divide by 1/2, that's the same. You have to flip and multiply, so it's the same as multiplying by 2. So 2, and I'm going to change my x to the 1/2 into a square root of x again, just so I can see what I'm calculating here. So now, I'll just plug these in. 2 times the square root of 9, and minus 2 times the square root of 4, which is 2 times 3, minus 2 times 2, or 6 minus 4, which is 2. And that is the correct answer for this one. Now this one, we're still finding the area under the curve. Since we want to find the area of the shaded region, we're going to do this in parts, because normally this part is negative because it's underneath the x-axis, and this part up here is positive. So we want to find the area, so we're going to take this piece and find it first, the left-hand side, and that's from negative 3 to 0. And our x cubed, negative x cubed one, is the curvy one here. And if we were to find the area just under it, then it would look like, let me get my pointer, we would be finding all of this. But we need to subtract out this part here, which is the area under the 4x. So we need to subtract. So we'll find this, and that'll give us this area, and then we'll find the area from 0 to 4, and I'm getting these numbers from our x's. This is negative 3, 0, and 4 here. So we want to do the exact same thing. And so we're going to take each of these, and I'm going to simplify that because the 16x minus 4x is just 12x. So negative x cubed plus x squared plus 12x dx. And this one is 0 to 4, same thing. So after we take our antiderivative one time, we're just going to use that same one to find the integral. So this one, if we add 1 to our exponent, that makes it an x to the negative x to the 4th divided by 4. And then add 1 to our exponent there and divide by that. And then do the same thing on the end. And if we add 1 to our exponent, we get a 2. And if we divide 12 by 2, we just get a 6. So 6x squared. And you can take the derivative of that to make sure that it's what you started with. And we're going to evaluate. And this one is, again, the exact same antiderivative, so we can just write it down again. And we're going to evaluate both of these. Once we evaluate both of these, we're just going to make sure that, because we're finding area, that whatever we get for this, or for this one, we make sure that it's positive, because we're finding area, and area is positive, even though we will get a negative underneath there. And then this one will be positive, and we're going to just get these two things separately. We're going to add them up. But once we put in, if we put in zeros for all of these, for the first piece, we're just going to get 0, and then we're going to subtract from that what we get when we put in a -3 into each of these x's. And when we do that, we're going to end up with a negative value here, but we want to make it positive because we're looking at area. And then we'll do the same thing down here. We'll put the 4's in for all of our x's, and then you can subtract what you get if you put zeros in, but you don't actually have to do that part because you just get 0, so you're going to subtract 0. So we'll get a positive number on this one, and then we'll just add those two together. What you should get is this 937/12. Now this last one that you were having difficulties with is the u substitution. So we are going to let u be that 4 plus x to the 6th. That means on the bottom here we have a u to the 3rd power. And then du, the derivative of u here, is going to be 6x to the 5th, which is what we have on top. So what we actually have is something of the form of u to the -3, because the u to the 3rd is on the denominator, du. And to evaluate those, or to figure out your integral for those, because we don't have numbers in there to find a definite integral, what we're going to do is add 1 to our exponent here. So if we add 1 to that, and then divide by what we get when we add 1 to that, then we add c, because we don't know if it has a constant or not. And then we just clean that up. That makes a u to the -2 over a -2 plus c. And if we want, we can put the negative out front. We can put our u on the bottom, so we have a positive exponent. And then we can just replace our u with what we said. I forgot my dx again. What u is right here. So 1 over 2 times 4 plus x to the 6th squared plus c, which is what we have right there.